Okay, this is Open Up Resources, Unit 2, Lesson 6, Using Equations to Solve Problems. This is for 7th grade math in our proportions unit. To get started, we are going to review what we've covered in the last couple lessons. Since today's lesson is going to be about using equations, we need to be proficient at writing equations. So to get started, we have this warm-up: write the equation for the relationship that you see in this table. Pause the recording until you've got your equation written, and we'll go over it when we return. When we're asking for an equation, we're asking for the relationship between x and y. How does an x change to become a y? And the first step in that is finding that constant of proportionality. The constant of proportionality, you can find it anywhere in the table. My favorite place to find it is right here. Whenever you have a 1 in the table in the left-hand side, it's very easy. How does a 1 change to become a 3? You just multiply by 3. And you can test that out, see if it works everywhere else. 2 times 3, is that still 6? Yep, 3 times 3, is it 9? And even the tricky one that I put at the very, very beginning, -1 times 3, is that -3? Yeah, everywhere in this table, to go across the table, I'm multiplying by 3. 3 is the constant of proportionality. And so that relationship doesn't change even if I start up here at the table at the label x. How does an x change to a y? All we have to do is multiply by 3. And it becomes a y. In other words, x times 3 is equal to y. That's what most of you typed into your calculator, x times 3 equals y. Some of you like it in reverse order, y equals 3x. That's just as great. Some typed it in 3 times x equals y, and that's also great. This was an interesting one. I had 2 students who wrote it this way, kind of going backwards. I don't love this, but it's completely 100% right. In our last lesson, which was on finding 2 equations for each relationship, they also said, well, if I'm going backwards, the relationship is we're multiplying by 1/3. So I can take the y, multiply it by the reciprocal of the constant of proportionality since I'm going backwards. Y times 1/3 is equal to x. So I have 2 students who wrote that. 100% correct. That's fantastic. Not the way that I would normally see that. And then the student who wrote it 2 different ways. Yeah, that covers all the answers on the quick poll. So nicely done. Have a solid understanding of writing equations, which is great because now we're going to be using those equations. We're going to start with a quick little number talk. So in this number talk, we're just doing some quotients. We're doing some mental math. We're not using our calculators. I don't even want you to use the long division algorithm either. I want you guys to just use some mental math. Look at the relationship between these numbers. I want you to order these quotients from least to greatest. So we have 42.6 divided by 0.07. 42.6 divided by 70, 42.6 divided by 0.7, and 426 divided by 70. So look at the relationship between all 4 of those and see if you can order them from least to greatest. After that, we're going to look at the relationship and we're going to try and figure out where is that decimal going to go when it's 42.6 divided by 7. Okay, pause the recording, use this. You can't talk about it with anybody if you're watching this video. You're probably alone watching it, but students in class are going to talk about it with their groups. Pause the recording now. Ready, set, go. Okay, here's what I'm going to do. I'm going to label these A, B, C, and D just to make them a little bit easier to talk about. Which one is the least? Which one is the smallest? If I'm putting them in order least to greatest, which one is the smallest one? And how do you know? Grant, go ahead and get me started. B is the smallest. Why? Okay, interesting. Okay. Dividend. Great. So to really be clear on all of that, the first thing that I notice is in A, B, and C, they all have that same dividend. The divisor is changing by just moving the decimal place in the divisor. D is different, so we can talk about that in a second. But if we're just comparing A, B, and C, we can see it's all the same dividend, only that divisor is changing. And so we can see that as we have talked about in this class before, the same amount of cookies and only the number of people that we're sharing them with is changing. This is going to be the smallest because it's the same number of cookies shared among the greatest number of people. Everybody's only going to get a small piece of a cookie. So B is the smallest. Let's just keep going among A and C, and then we can squeeze in D where it goes. So just among these ones, A, B, and C, which one's the next smallest? Going along with that same line of thinking. Go ahead, Cambria. Yeah, I would say C is next. Because again, same number of cookies, but now the number of people got a little bit smaller, so that means it's going to be bigger. And using some of the thoughts that Grant had shared, this number is greater than 1. These numbers are less than 1. So when I divide by numbers less than 1, those numbers end up getting bigger and bigger and bigger. And so that means, if I'm just comparing A, B, and C, that means A is going to be the biggest here, right? Where does D fit into all of that? Joshua. Less than A. Okay, so it would go in here. I didn't follow that line of thinking very, very closely. You try it one more time. I feel like when you explained it, you maybe moved the decimal place a few too many times, at least in my head. Will you try it one more time, Joshua? Okay. Okay. Careful. And that's where I think your mistake came in. 426 divided by 10 is only going to be 42.6, not 4.26. Okay, got it now, got it now. And dividing this part by 10 as well, that's going to be that, right? Okay, now carry on with that line of thought. Mm-hmm. Okay. Okay, I follow it now. I think that's great. It was hard to compare 426 to 42.6. All the others were 42.6. So if we just say, well, let's just move the decimal place on each, or in other words, let's divide each of these, both divisor and dividend, by 10. Now we have 42.6 divided by 7, and then it follows the same sort of pattern as everything else, which means it's going to slide right in here between that B and that C, B, D, C, A. Any thoughts, questions, comments? Okay. Now, with that in mind, we now have that 42.6 divided by 7, which is how we can think of part D. If that's the case, where does that decimal place go? Where among all this 608571, where is that decimal place going to go? Anybody? Go ahead, Carter. Yeah, right after the 6. How do you know that? Okay, yeah, good. If we get rid of this 6/10, if we just know 42 divided by 7 is 6, then it's going to be 6 and some change because we've got some change right here. Yeah, it's a good thought process. Anyone else see it a little bit different? Warren, you had your hand up too. Did you think about it any differently? Same thought process there? Great, I like that. So all of that is mental math, guys. It's numeracy. It's looking at patterns between these numbers and doing these things without needing a calculator. So really nicely done. For the sake of time, we are going to skip part B. Let's move on. For this one, it says a performer expects to sell 5,000 tickets for an upcoming concert, and they want to make a total profit of $311,000 in sales from these tickets. Not necessarily profit, but make that much in sales. So assuming that all tickets have the same price, what is the price for one ticket? What we're saying when we're asking what is the price for one, we're asking for that unit rate. The next question says, using the unit rate from that last problem, we want to write an equation to represent the amount of money M for X tickets. You can make a table if it helps. And we'll do all of that together after students have had a chance to work on it. And then number 3, we're using that equation. We now will take, after we write the equation, we're going to use the equation to answer all of those questions that follow. Okay, so let's at least start 1 and 2. If you have extra time and are getting bored, then answer all of the parts of question 3. But what is that unit rate? What is the price for 1 ticket? And how does that help us write an equation? With your groups, ready, set, go. When we're finding the unit rate, what I'm really doing is I'm taking a ratio and I'm finding an equivalent ratio, but I'm doing it in a specific way. This is our $311,000. These are the 5,000 tickets. So it looks like a fraction, but it's a ratio because I'm using my units here at the beginning. And I want to know the price for 1 ticket. So I'm asking, how does that 5,000 change into a 1? It's an easy question. Just like when we find that 1 on our table, it's an easy question. This is an easy question too. How does any number change to a 1? We just divide it by itself. So how am I going to find, or what should I be doing since it's equivalent ratios? I should be doing the same thing. 311,000 divided by 5,000. And in our calculator, please tell me what you got. Cambria. 62.2. Now making that answer quantitative, we know that 62.2 means $62.20 for 1 ticket. How I'm going to show my work when I find a unit rate. And that's important because I know that this is something that we would just type into our calculator, but showing how it relates to our equivalent ratios is a really good added benefit. Now it says use the unit rate from the last problem to write an equation that represents the amount of money M for X tickets. And it says make a table to help. So here's what this is going to look like. I'm not going to make a whole full-on table, but I am going to show that if X is the tickets, and M is the amount of money, in this short little table, it's going to have this information. It's going to have 1 ticket is going to be $62.20. I know that because we just found that here in that last problem. If I wanted to, I could even include this amount here, that 5,000 tickets would be 311,000. Just a tiny little table, but it helps me to clarify, it helps me to see that relationship. How does a 1 change to a 62.2? Well, it must be multiplying by 62.2. That unit rate is also our constant of proportionality. So what is that equation? I'm going to take the x, multiply that x by 62.2, and that is how I find my equation, my m. So I have x multiplied by the constant of proportionality, 62.20, and that is equal to m. The reason I think that this is a helpful step, this step right here, making a table, is all of our practice up until this point has been writing equations from a table. So we're most practiced and most experienced with using those tables. So if you don't have a table, make a table. Once you make a table, this becomes a very, very familiar problem and you know exactly what you need to do. So here's our equation. Of course, there's all those other different ways of writing it. M is equal to 62.2 times x. And that's helpful because problem 3, we're now using that equation. How much will they make if they sell 7,000 tickets? How much will they make if they sell 10,000, 50,000, 120,000, a million X tickets? How much money are we going to make? And if they make $379,420, how many tickets have they sold? How many tickets would they have to sell to make $5 million? I'm going to pause the recording again one last time, let you guys work on these. Ready, set, go. How much money will they make if they sell 7,000 tickets? Notice what all of this means. This X represents the tickets. So when I'm saying 7,000 tickets, that means I know what X is. X is 7,000. What do I do with the number of tickets? We take that X and we multiply it by 62.2. And that gives us our M, the amount of money. So 62.2 times 7,000, and I can't do that one in my head. So those of you who have calculated it, Luke, I saw your hand raised a little bit earlier. What did you get? 435,400. Did I write that down correctly? Okay, nicely done. So again, that's our abstract answer. Quantitative is exactly what Luke said, $435,400 for 7,000 tickets. How much will they make if they sell 10,000 tickets, or 50,000, or 120,000, or a million? What are we going to do with each one of those amounts? What should I do with every single one of those? Oren. Exactly. Multiply them by 62.2. So we're just taking the x, taking the number of tickets, substituting in each of these values into that equation, which says x is multiplied by 62.2. And so real quick, I'm not going to show my work as nicely on these ones, just so I have the space to write it. 10,000 tickets, what is that going to be? I'm just going to write it right below. Cambria? 622,000. Yes. Yes. Is that right? That's right, right? The answer key shows something different. Yeah, the answer key shows something different, but that is correct. 622,000, so I would need an extra zero. Is that right? That's better. Okay. $622,000. What about 50,000? What's that going to be, Trace? Okay. Let's... Very good. 3,110,000. You got it. And I didn't draw enough zeros. There we go. Okay, and 120,000. Anybody have that one calculated? Go ahead, Carter. You're close. You're missing the first digit. Help him out, Grant. Yes. Yes, you got it. Carter had the 464,000, forgot about that 7 million at the beginning. Yeah. And now for X tickets, what's that going to be? Well, that's just our equation, right? For X tickets, it's X multiplied by 62.2, or in other words, 62.2X. Oh, I forgot a million. We're going to skip that for the sake of time. If they make $379,420, how many tickets have they sold? How is this different than the last questions? What are we going to do this time? What are we going to do this time? Go ahead, Davin. Exactly. This time I've told you what the M is, what the money is. So instead of changing the X to that 379,420, that's the M. The M is changing, or we're substituting in for M 379,420. So 379,420 is equal to 62.2x. How do I take care of this? Because that still doesn't answer the question. I was able to substitute it in, but now what do I do with that information? Davin, do you want to finish that up for me? Yeah, exactly. It's just an equation that we need to solve, right? So rewriting it up here so I have a little bit of space to show that thought process. I say, hey, what's happening to x? It's being multiplied by 62.2. How do I undo that? We divide. And whatever I do to one side, I do to the other side. This divides out, and it tells me then that for x number, or the number of tickets, which is x, is going to be, I need some help here. What is 379,420 divided by 62.2? Joshua, do you have that calculated for me? Yeah, 6,100 tickets. Nicely done. So again, making sure that we're paying attention to what values they're giving us and where they belong in the equation. That's going to be really important here. How many tickets will they have to sell in order to make $5 million? So same concept, only again, I'm not giving you the X, I'm not giving you the number of tickets. That's the question that I'm asking. Go ahead, Grant. It is, yes. So remember, again, we're changing the M, the amount of money, is being substituted for 5 million. 5 million is equal to 62.2 times X. So now I have an equation to solve. I undo this multiplication with division, whatever I do to one side. We do it to the other side. And that is how I get $80,386 is equal to X. All right, let's move on. This one is an interesting one. I really like this problem, but it ties in a whole bunch of extra information that can be a little bit dizzying. So we're going to go over this one together. I'm not going to have you guys work on this one on your own. It says aluminum cans can be recycled instead of being thrown in the garbage. The weight of 10 aluminum cans is 0.16 kilograms. The aluminum in 10 cans that are recycled has a value of 14 cents. Write an equation to represent the number of cans given their weight. Notice what happened here. There was 3 different pieces of information given. The weight of 10 aluminum cans is 0.16 kilograms. The aluminum in 10 cans that are recycled has a value of 14 cents. There's extra information given here. Let's see if we can find the right pieces of information. The equation that represents the number of cans given their weight. Here's where the weight is. But we need to tie it into the number of cans. Did you guys notice that there was that extra information given each time? 10 aluminum cans and 10 cans. So we can actually write 3 equations, which we are going to do. Write an equation that represents the number of cans given their weight. And again, whenever I'm stuck on this, I'm going to make a little mini table. I'm comparing the cans to the weight. So here's the number of cans, and here is their weight. So 10 cans, 10 aluminum cans, has a weight of 0.16 kilograms. Now that I've got a little table, hopefully that helps me out a little bit. How does the 10 change to a 0.16? If you don't know how to do that, go backwards. Let's review that. If I don't know how to go forwards, then we're going to work backwards with division. 0.16 divided by 10. And 0.16 divided by 10, you get... Come on, guys, you all have calculators. Gideon, what do you got? Exactly. 0.016. So that means to go forwards, I'm multiplying by 0.016. Or in other words, the number of cans is multiplied by 0.016, and that gives us the weight. We now have a relationship tying together the number of cans and their weight. Here's another way that we could have done this. Now, let's just move on. For the sake of time, let's move on. Write an equation to represent the recycled value R, that means how much they're worth, of C cans. So again, we're comparing R now, the recycled value, which is 14 cents, to the number of cans. Make a little miniature table. The number of cans and its R, its value. Well, just like before, remember we have 10 aluminum cans, and that has a value, as we can see here, of 14 cents. Now I said on the last problem there's another way we could have done this. I'm going to show you that other way right now. I don't know how a 10 changes to a 0.14, but I can think of this as equivalent ratios. I'm going to change a 10 to a 1. How does a 10 change to a 1? We just divide by 10, right? So what am I going to be doing with the other part of that ratio? Divide it by 10. Now 1 can is going to have a value of, let's see, what's 0.14 divided by 10? That's going to be 0.014. And now doesn't that become a lot easier? How does a 1 change to a 0.014? We must be multiplying by 0.014. So the number of cans multiplied this constant of proportionality, 0.014, is equal to R, the recycled value, the amount of money that it's worth. And the last one, this time we're relating R to W, the value to the weight, which is really, truly how you're paid. You're not paid for the aluminum cans based on how many cans there are. You're paid based off of the weight. So now I want to go R, we're going to go W to R. W to R. Help me fill in this table. Yes, Grant? I don't want the equation yet. Let's build our table so that we can then write the equation. What would I put in the W column? Go ahead, Grant. Yeah, 0.16, because 10 aluminum cans weigh 0.16 kilograms. So the weight is 0.16. And those same 10 cans have a value of 0.14. So that's what I'm going to put over here. And again, I'm not sure how a 0.16 changes to a 0.14, but I can always work backwards, right? So what is that constant proportionality? Grant has already done it. 0.14 divided by 0.16 is our constant of proportionality. So going forward, I'm multiplying by what, Grant? Yes, 14/16 as a fraction, but 14/16 could be simplified. What would 14/16 be simplified to be? Go ahead. Let's give it to Luke. It would be 7/8, and as a decimal for those who did it as a decimal. Trace? Yeah, nicely done. 14/16 simplified is 7/8. 7/8 as a decimal is 0.875. So that is what we are multiplying by, which tells us our equation. Once we know that constant proportionality, we know the equation. W multiplied by 0.875 is equal to R, the value. So that helps me answer the next couple of questions. If a family threw away 2.4 kilograms of aluminum in a month, how many cans did they throw away? Then the next question, what would the recycled value of those same number of cans be? So two different questions. We're going to be using two different equations for that. Which equation are we going to be using for number 4? Again, it says if a family threw away 2.4 kilograms of aluminum in a month, how many cans did they throw away? Which of those 3 equations is going to be the most helpful? Talk with your groups. Talk with your groups first real quick. Quick discussion here. Okay. Which equation is going to help us answer this question? Gideon. The first one, because the first one relates weight, which is what we're given. We're given weight. Where did my cursor go? We're given the weight, and we're asking about how many cans. So it's this first one. That's exactly what we're going to do. Let's rewrite that one. C times 0.016 is equal to W. But I know the W, the weight that it gives me in this problem, the weight that we should be using is 2.4. So C multiplied by 0.016 is equal to that 2.4. And just like before, we can see that C is being multiplied. I'm going to undo that multiplication with division. Whatever I do to one side, I need to make sure I do to the other side. So I have C is equal to, and again, your calculators are going to be helpful here, 2.4 divided by 0.016. Whoever has that, let me know. Oh, you're going to make me calculate it myself, aren't you? 2.4 divided by 0.016. Thank you. Dylan. Joshua, sorry. It is 150. 2.4. Guys, you need to know how to do this, so don't rely on everyone else to do the work for you. What you should have done in your calculators is 2.4 divided by 0.016. It doesn't take you very long. Type it in yourself, and you can confirm that Joshua got the correct answer. That's Math Practice 3. Construct your own viable argument so you can critique the reasoning of others. The number of cans is 150. Now, there's 2 different ways that we can do number 5. Now that we know the number of cans, we can either use this one, the number of cans multiplied by this constant of proportionality will give us the value, or we can go back to the original information and compare it with the weight. I'm going to do that one. The weight is 2.4. So I'm going to relate the weight to the value. The weight that it gives us is in this previous problem. It's that 2.4 kilograms, so that weight is 2.4. We take that 2.4, we multiply it by the constant proportionality in that equation, 0.875, is equal to R, the value. When I recycle those 150 cans, or those 2.4 kilograms of cans, what do we get? Again, please use your calculators. Don't rely on anyone else to do the work for you. You should be doing it for yourself. And I got, hopefully the same as Tanner. What did you get, Tanner? Yep. You're rolling in the dough, aren't you? Saved them for a whole month, and how much money did you make? $2.10. That's right. You're rolling in it, aren't you? Filthy rich with those $2.10. Don't spend it all in one place. Okay. We're going to skip the Are you ready for more? Let's do our lesson summary so we can be done and get out of here. Remember that if there is a proportional relationship between two quantities, the relationship can be represented by an equation of the form y equals kx. Sometimes writing an equation is the easiest way to solve a problem. For example, we know that Denali, the highest mountain peak in North America, is 20,300 feet above sea level. How many miles is that? There are 5,280 feet in a mile. So we have this equation, F is equal to 5,280 m, where F represents the distance measured in feet and m the same distance measured in miles. And since we know that Denali is 20,310 feet above sea level, we can write that equation substituting F for 20,310. We can then solve this equation and know that that is approximately 3.85 miles. All right, and now for the cool down. Based on her recipe, Elena knows that 5 servings of granola have 1,750 calories. The first thing I'm going to do before anything else, I'm going to skip ahead to number 3 and I'm going to write the equation. So what I see here is I see some information, I see a relationship, and I'm going to turn that relationship into a table. I can see that this table is going to show the relationship between servings, which is 5, and calories, which is 1,750. So the first thing I want to do now that I have this relationship is I'm going to find that constant of proportionality. How does a 5 change to a 1,750? I don't know. So I'm going to have to work backwards, and when I work backwards, that means I'm going to be using division. So 1,750 divided by 5. And that gives me 350. So that means when I'm going forward in this table, I'm multiplying by 350. That's the constant of proportionality. And that also tells me what that equation is going to be. I'm going to call this, I don't like using S because S looks a lot like a 5. So I'm going to call this V for servings and C for calories. So the V is going to be multiplied by 350, and that is going to tell me how many calories there are. Now that I have this equation written, so again, I skipped ahead to number 3. Now that I have that equation written, now I can use that equation to answer these other questions. If she eats 2 servings of granola, how many calories does she eat? That means that in this equation, the V times 350 is equal to C. I'm changing that V to a 2. The V, the servings, is 2. Multiply that by 350, and it will tell you the number of calories. 2 times 350 is equal to C, so C is equal to 750 calories. Now, in the next one, we're using the equation in a different way. It says if she wants to eat only 175 calories of granola, how many servings should she eat? The same exact equation, only this time instead of the V, the number of servings, she's giving us the number of calories. So that C is going to change to 175. That's the number of calories. And here's the equation, that V multiplied by 350. So again, V multiplied by 350 is equal to 175. I need to solve this equation, so I divide each side by 350. And when I do that, I end up with V is equal to 1/2. And that is it. Your practice problems are the Unit 2 Lesson 6 homework section, or practice problems. That's your homework. Thanks for watching, and we'll see you next time.